Hello, everyone, and welcome back to Chapter 10 on motivation and emotion. What drives you to get out of bed in the morning, chase your goals, or comfort a friend? And why do some days feel like a sprint fueled by purpose, while others feel like walking around through mud? In this chapter, we're going to cover and explore what fuels human behavior, the biological and psychological forces that push us to act, to feel, and to keep going. We'll also explore how motivation and emotion are connected, shaping everything from survival instincts to personal growth, relationships, and decision making. By the end of this chapter, hopefully, you'll see how the same systems that make your heart race when you're excited also help guide your choices, habits, and your sense of purpose. Moments can flip our feelings really fast. In a sudden crisis like the Boston Marathon bombing, people in the same place felt very different things and acted in very different ways. Some ran towards others to help, while others moved to safety. That split is a powerful snapshot of how emotion and motivation work together. Emotion is the felt state: fear, shock, urgency, compassion. Motivation is the push that follows, so the approach, avoid, freeze, or plan. The same event can trigger different appraisals in different people. I can help, or I need to get out, or I have to find my family. These responses shape the emotion and the emotion channel's behavior. As we move through this chapter, keep this picture in mind. One stimulus, many internal responses, and many paths of action. It's the link between what we feel and what we do next. So let's look at two common sources of motivation: intrinsic motivation and extrinsic motivation. Intrinsic motivation comes from within. You do the thing because it feels satisfying or meaningful: curiosity, enjoyment, pride in getting better. There's no prize needed. Extrinsic motivation comes from outside. You act to earn something or avoid something, so grades, pay, praise, approval, or deadlines. These can be useful, especially for short-term goals or when you're building a routine. Both kinds point behavior towards a goal, but they feel different from the inside. Intrinsic tends to support deeper focus and longer persistence. Extrinsic can get you moving when you might not want to start otherwise. Most of us use a mix that shifts with context. As you think about your own habits, notice which one is doing the heavy lifting on a given day. Overjustification is what happens when a task we already enjoy starts to feel less interesting after we add an expected external reward. The activity shifts from "I do this because I like it" to "I do this to get something," and the spark tends to fade. But results differ depending on how we reinforce. Tangible rewards like money or prizes often reduce intrinsic interest, especially when people expect them. Intangible feedback, like specific or sincere praise, can support or even increase motivation because it signals competence rather than control. Expectation matters. When a reward is expected, it's more likely to pull attention away from enjoyment, and when feedback feels informational, it tends to keep engagement steady. William James described behavior as driven by instincts, built-in patterns that help survival. Classic examples include a mother protecting her baby, the tendency to prefer sweet tastes or sweets, and hunting-like pursuits. We still see prepared tendencies in humans, so newborn rooting and sucking are good examples of this. The theory's limit was that it didn't account well for learning, culture, and wide differences in human behavior. It's a useful historical lens, and it drew attention to biology, but it can't stand alone to explain everyday motivation. Drive theory starts with homeostasis. That's the body's balance. When we drift from balance, we feel a physiological need that creates a drive to act. We do something to return back to balance. When a behavior reliably reduces a drive, it becomes a habit we're likely to repeat the next time the same need shows up. Hunger and eating are straightforward examples, but the same loop shows up in many everyday behaviors. So, what I tell clients in my office is that the behaviors and the actions that they take, sometimes that's coping skills that aren't necessarily the healthiest, but they're helpful, is that it is the biologically correct response given the state of the nervous system of the body in that point in time. So, what that means is they recognized a deviation, or their body recognized a deviation from the balance, and identified a need and did something to get that need met, whatever that may be sometimes. Arousal theories say we work best in a just right zone. So when arousal is too low, we feel bored and go looking for stimulation. When it's too high, we try to dial things down. Most of the time, performance is strongest right in the middle. Enough energy to focus, but not so much that we're jittery or scattered. Think about how you study. Some of you settle in better with a little light background activity, while others need quiet to keep from tipping into overload. The target is moderate arousal for most tasks and adjusting the environment when you drift too high or too low. Yerkes and Dodson add an important detail to this. The best arousal level depends on the task. Difficult or complex work usually benefits from lower arousal and fewer distractions. So fewer distractions, calmer pacing, and simple or well-practiced tasks can handle higher arousal, like timers, light pressure, or even music. So you match the setting to the job, turning things down for new heavy material and turning things up for a bit more of routine practice things. Self-efficacy is your belief that you can do the task in front of you. Bandura showed that this belief shapes motivation. If you expect your effort to work, you're more likely to start, stick with it, and set bigger goals for yourself. It's not empty confidence, it's just a judgment built from your experiences, feedback, and models that you've seen succeed. We're also moved by social motives. The need for achievement pulls us towards challenging goals and solid performance. The need for affiliation draws us into positive, cooperative interactions, and the need for intimacy pushes us into deep, meaningful relationships. In real life, these motives mix, pursuing competence, connection, and closeness in different proportions depending on the setting. We're going to translate or transfer back to Maslow for just a moment. Maslow framed motivation as a stack of needs from basic to growth oriented. At the base are the physiological needs like food, water, and shelter, followed by safety, love and belonging, esteem, and self actualization at the very top. The idea is simple: when lower level needs feel unstable, they take priority. If you're worried about meals or housing, it's hard to focus on relationships or your reputation. When the basics are steady, attention can shift upwards towards connection, confidence, and personal growth. Treat this as a lens and not a rigid ladder. People can move up and down, and culture and context shape how needs show up. So we've looked at what gets behavior going and how arousal and belief shape effort. Now let's ground that in something that you maybe feel every day: eating. Think about the late afternoon snack, or losing your appetite when you're really stressed, or how weekends change your routine. Those moments come from body signals that rise and fall, the way your metabolism uses energy, and the environments you move through. From there, patterns build, weight trends over time, and for some, health concerns and disordered eating. This next stretch connects those everyday experiences to the systems behind them: hunger and fullness cues, metabolic processes, obesity, and eating disorders. Hunger isn't just willpower. It is a very coordinated system. Before eating, an empty stomach contracts and sends its time to eat signals up to the brain. Low blood glucose triggers the pancreas and liver to release chemical cues that nudge feeding behavior. After eating, satiation, that feeling of fullness, helps you to stop. Rising blood glucose and signals from the gut tell the brain to shut hunger down. So in short, the body cues start the meal and different body cues help end it. When the system is balanced, these signals guide timing and portion sizing without you having to think much about it. But body weight reflects more than just calories in and calories out. Genetics interact with our environment, activity, and metabolic rate, how much energy that you burn over time. And people vary. Some burn energy really fast, while others conserve more. Set point theory proposes that each body, each person, tends to defend a preferred weight range. Push far from that range, and the body often is going to compensate for it, so changing your appetite or the amount of energy that you have or use to drift back. Set point helps explain why weight can fluctuate within a narrow band, but it doesn't fully capture social and environmental influences. Access to safe spaces to move, food options, and work schedules, all of that's important too. BMI categories are a quick screening tool that some providers use to see what is going on for a person. You can see the different ranges. 25 to 29.9 is overweight, over 30 is considered obese, and over 40 is often called morbidly obese. Many US adults struggle somewhere on this spectrum. The chart on the slide shows how BMI is calculated, so you can find your height on one axis and the weight on the other. But numbers are not the whole story. Environment plays a real role in this. If a neighborhood doesn't feel safe for walking or biking, activity levels are going to drop. If healthy food is expensive or hard to reach, our choices are narrow. Genetics and energy balance still matter, but daily context can shift the scales towards or away from weight gain. Sustainable weight reduction usually pairs nutrition changes with movement, so diet and exercise put together. For some, bariatric surgery becomes part of the plan, so procedures like gastric banding reduce the usable stomach volume, which can change intake and over time can change weight. Surgery is a medical decision with risks and follow-up care, and it's not a quick fix by any means. Whatever the path, long-term support around eating patterns, activity, sleep, and stress tends to help the changes stay over time. Eating disorders are disruptions of patterns of eating and body image, and they can be medically serious. People may see their bodies in ways that don't match reality and engage in behaviors that harm their health. Consequences can include bone loss, cardiac problems, hormonal changes, fertility issues, and in severe cases, even death. Psychological concerns can also often co-occur, so anxiety, mood symptoms, and substance use. These are complex conditions that deserve compassionate, evidence-based care. So, bulimia nervosa involves recurrent binges, so episodes of eating a large amount of food with a sense of loss of control, followed by compensatory behaviors to try to undo the calories that were taken in. That can include self-induced vomiting, laxative or diuretic misuse, or excessive exercise. This cycle can be medically dangerous. Electrolyte shifts raise the risk for heart and kidney problems, and repeated vomiting can erode tooth enamel and irritate the esophagus. Psychologically, bulimia often co-occurs with depression, anxiety, and increased risk for substance use. People can fall anywhere on a spectrum of frequency and severity, and many hide their symptoms out of shame, so compassion is really important here. Anorexia nervosa centers on restricted intake and significantly low body weight, often maintained through starvation or excessive exercise. A key note here is the distorted body image. A person may see themselves as fat even when underweight. Medical risks are also really serious, with bone loss, cardiac complications, kidney issues, hormonal disruptions, such as loss of menstrual periods, and in severe cases, death. Co-occurring anxiety and mood symptoms are also common, and rigid perfectionistic thinking can keep this disorder going. Across both of these disorders, what you're seeing aren't necessarily choices so much as learned patterns that reduce the distress in the short term while creating health risks over time. Effective care is multidisciplinary and typically have medical monitoring, nutrition support, and evidence-based therapies delivered without judgment, preferably. And the risk is shaped in many, many layers. So we have cultural messages like constant exposures to the thin ideal can fuel the dissatisfaction. Genetics also raise vulnerability. Life transitions, stress, low self-esteem, and experiences like bullying or abuse all add weight to the system. Certain personality traits, such as perfectionism and family stress, can also contribute. There isn't just one cause, it's usually a mix of factors that look different across everyone. And early recognition and help can help change that for some people. So now let's connect biology and behavior, the brain systems involved in sexual motivation, landmark research in human sexuality, and how we talk about sexual orientation and gender identity. The hypothalamus is the hub for motivated behavior, including sex. In animal studies, damage to the medial preoptic area disrupts sexual performance, yet animals may still seek access to a mate, suggesting that the ability to engage and the motivation to pursue are mediated by different parts of the brain. In humans, disorders that affect the hypothalamic function can show up as changes in sexual function and in hormones related to reproduction. Motivation and performance run on overlapping but not identical systems. The amygdala and nucleus accumbens help code salience, reward, and approach. They're involved in the motivation for sexual behavior, even when the ability to engage is intact. In animal work, damage here reduces the drive to initiate sexual behavior without eliminating capacity. Think of those regions as part of the Y-act circuitry, so tuning interest, pursuit, and reward learning. In the late 1940s, there wasn't much empirical data on human sexuality. There was lots of assumptions and very little measurement. Dr. Alfred Kinsey changed that by running a large-scale survey on people's actual experiences. And when the data came in, patterns that many thought were rare turned out to be far more common than expected. Kinsey's work didn't tell people what should be happening, it described what was already happening. And that, from moral opinions to observed data, reshaped the field. It opened the door for more systemic research on sexual behavior and motivation, and it challenged myths that were limiting how scientists, clinicians, and the public understood typical human variation. What his data showed were behaviors that were widely labeled as uncommon were frequently reported, including masturbation, premarital sex, and same-sex behavior. Kinsey also introduced the idea of an orientation continuum, often called the Kinsey scale, highlighting that many people's experiences don't sit at the extremes. These findings helped replace myths with measurement and broadened how researchers understand typical human sexuality. Masters and Johnson brought measurement to the physiology of sex. They observed people engaging in sexual behaviors and tracked changes in the body: blood pressure, breathing, vaginal lubrication, penile tumescence. Their model describes four phases: excitement, which is where arousal begins; plateau, which is the intensifying responses; orgasm, which is rhythmic contractions and ejaculation; and resolution, which is a return to baseline. Sexual orientation refers to a relatively stable pattern of emotional and/or erotic attraction towards others. It's not a choice. 3 to 10% of adults identify as homosexual. Earlier ideas pointed to different upbringing or experiences haven't held up. Those factors can be similar across orientations. Research instead highlights biological and genetic contributions, including differences observed in brain structure and function at the group level. And as always, we talk about people, not stereotypes. Human variation is real and respect is non-negotiable. Gender identity is a person's internal sense of gender. For many, that aligns with sex assigned at birth, and for others, it does not. Gender dysphoria is a clinical term used when a person's experienced gender and assigned sex don't align, and this causes significant distress or impairment for at least 6 months. Some people pursue gender-affirming hormone therapy to help their bodies better reflect their identity. Our language follows people's self-described terms, and we avoid assumptions. Chaz Bono is a transgender man whose public transition helped many people see what it means to align one's external presentation with one's internal gender identity. Examples like this help remind us that identity is lived and it's not theoretical. Laverne Cox is an openly transgender actress and advocate. Her visibility has expanded understanding of transgender experiences in mainstream media. And when we discuss gender identity, we keep the conversation respectful, evidence-based, and mindful that other people may hold different identities or beliefs, and that's okay. So we've talked about sexuality, how our bodies, brains, and identities show up in real life. Now let's transition to something that you feel all day long, emotion. Think about your chest tightening before you hit send, the calm that settles after you take a deep breath, or how a friend's laugh can lift your mood without even a word. Those sudden changes shape what you notice and then what you do. Moods are longer lasting, lower intensity feeling states. They don't have a clear starting event and can sit in the background even sometimes without us noticing why they're even there. Emotions are shorter and sharper, subjective feeling states that usually follow an experience or appraisal of a situation. Because emotions are more intense, they tend to grab attention and shape behavior very quickly. Moods color the day more quietly. Keeping the two separate helps when we talk about causes and regulation, what sparked a fast emotional shift versus what set the tone for your afternoon. Emotions can turn on a dime. You've seen it in toddlers, huge joy and happiness, then sudden sadness or upset. Adults feel quick flips too, we're just better at masking them. That speed comes from fast appraisal systems in the brain that prime the body to act before we've put words to the feelings. The point here isn't that emotions are just random, it's that they're very responsive or reactive. They rise and they fall as situations change. There are several theories of emotion. So the first one is the James Lange theory, where the body changes first and then the feeling follows. So, for example, you see a snake, your heart and respiration rate increase, so you have physiological arousal, and then you notice a feeling of fear. A couple other examples here are you hear a sudden crash in the hallway, your heart jumps, your muscles tense, your hands start to shake, then you register, I'm feeling scared. Another example is you spot a crush across the room, your face warms and your stomach flips, and then you realize I'm embarrassed or I'm excited. The Cannon-Bard theory says that the brain triggers feeling and body changes at the same time. So you see the snake and physiological arousal and fear arise at the same time. Or a few other examples. A car swerves towards your lane. In the same instant, you feel fear and your heart races. Or you open a surprise acceptance email. Joy hits you as you grin and exhale. Emotion and arousal together, not one after the other. These two models differ on timing, body then feeling, versus feeling and body together. Then we have the two-factor model, where emotion is arousal and a cognitive label. So arousal by itself is ambiguous, and the situation helps you name it. Sweaty palms and a racing heart could be fear on a dark walk or nerves before a presentation. So, for example, your heart's pounding. In a dim parking lot, you label it as fear. Standing side stage before your name is called, you label the same body state as excitement. Or after strong coffee, you feel really jittery. During a tense argument, you label it as anger. And with friends before a concert, you label it as hype. Same arousal, different labels, and different emotional states. We have the cognitive mediational approach theory, where appraisal comes first, so often fast and outside of your awareness. Your evaluation of the situation shapes both the feeling and much of the bodily response as well. So, for example, you spot a coiled shape in your yard. If your instant appraisal is snake equals danger, fear surges and your body gears up. Then you take a second look and it reappraises it as a hose and that feeling drops. Another example is an email pings and says, hey, can you meet this afternoon? Appraise it as I'm in trouble and anxiety is going to rise, but appraise it as a routine update and you stay neutral or even curious. Together, these models highlight interpretation. We don't just feel, we make sense of arousal and context, and that process drives the emotions that we experience. So let's look at how these models compare using the same example. I know this image is a little blurry, bear with it. So the first theory, the James Lange theory, the body moves first. So you see the snake, your heart rate kicks up, muscles tense, maybe you take a step back. After those changes, the feeling registers, that pattern in your body is read as fear. In the chart, notice the order here is we have our stimulus, which is seeing the snake, the physiological arousal of the heart pounding and sweating, and then it leads to the emotion of fear. The Cannon-Bard theory will say that the brain sends two signals at once. The moment that you see the snake, you feel fear and your body revs together. There's no waiting for the body to finish before you feel it. And on the figure, we see the two branches run parallel to each other from the stimulus. In the two-factor model, your body still revs, but the name of the emotion depends on a quick appraisal of the context. Snake on the trail plus arousal is you label it as fear. And if it were a rubber snake at a prank table, the same arousal might get labeled as surprise or embarrassment. And then in the Lazarus model, we start with a quick appraisal. So you see the snake and your mind evaluates it. Is this dangerous or is this safe? That appraisal comes first and shapes both what you feel and how your body responds. So think stimulus leads to the appraisal, and then from the appraisal, we have the emotion with the physiological activation. So if the appraisal is danger, fear rises, body gears up, and if it's a rubber snake, you appraise it as harmless and the feeling shifts accordingly. So same snake, different path that your brain may take. Emotion and memory lean on a network. The hypothalamus helps kick off sympathetic nervous system activity, those body changes that come with strong feelings. The thalamus relays sensory input both to the amygdala and to the cortical areas for further processing. Fast route and thoughtful route. The amygdala tags emotional significance and helps send that information forward. The hippocampus weaves emotional experiences into memory, linking what happened with how it felt. The amygdala is a huge role in biology of fear and anxiety. It includes the basolateral complex, densely connected with sensory areas and important for classical conditioning, and attaching emotional value to learning and memory. The central nucleus helps direct attention and connects with the hypothalamus and brainstem regions that drive autonomic and endocrine responses. The body side of the emotion. Think, is this important, and prepare the body are working together. Cultures teach display rules, when, where, and how it's acceptable to show emotion. In some settings, like the United States, people may show negative emotions like fear, anger, or disgust, both alone and around others. In others, for example, classic studies of participants in Japan, people dampen those expressions in social contexts. Even with different rules about display, people are generally good at recognizing core facial expressions across cultures. Across cultures, there's broad agreement on facial patterns for a set of emotions, often listed as happiness, sadness, fear, anger, surprise, disgust, and contempt. The exact labels may vary by source, but the idea is the same. Certain expression patterns are widely recognizable even when people grow up with different display rules. Does smiling make you feel happier, or do you smile because you're already happy? The facial feedback hypothesis says that the muscles you use to make an expression can shape what you feel. When your face forms a smile or a frown, the body sends signals that can nudge your emotional state in that direction. And there's support for this as well. For example, some people with depression reported less depressive feelings after Botox injections that temporarily reduced frowning. So less ability to frown, slightly less pull towards sad affect. The sequence here is simple to picture. We have our emotional stimulus, leads to our facial expressions, changes in our body, and then we have a felt emotion. This doesn't mean fake a grin and everything's fine or fake it till you make it. It means expression and emotion run in a loop. Small shifts in the face can feed back into how the moment feels, one tool among many for helping regulate emotions. This is also why if you watch a funny video when you're feeling sad or angry, it can help to lessen the emotion you were feeling prior. Self. It's the core of our daily life. They power our choices, shape our habits, and color the way experiences feel in our bodies and our minds. As you leave this chapter, notice small moments. What nudged you to start something? What kept you going? and how a feeling shifted once you reread a situation. Understanding motivation and emotion helps you make sense of others and also yourself.